Okay, for number 6, okay, we have the introduction of integrating in order to solve inverse Laplace transforms. Now, your original Laplace transform is going to be 2 over s squared times the quantity of s minus 5. And for f of t, the inverse Laplace transform of this directly is going to be in terms of integrating what you have in the problem, where we had the appearance of the integral as tau goes from 0 to t of the inverse Laplace transform of 2 over s times the quantity of s minus 5. And again, multiplying the Laplace transform by s, again, so you have in the s factor, you have to go down by a degree once you express in terms of integrating. Now, taking the partial fraction decomposition of what we have in the inverse Laplace transform within the integral, we have with our linear factors, we have s and s minus 5, and clearing out the fractions, and we have the equation in terms of the variables a and b, and we have two unknowns, and there are zeros that we can apply and to eliminate the presence of b, I can set s to 0, and to eliminate the presence of a, I can set s equal to 5. Okay, so by negating b, I can solve for a, and we have, in effect, negative 5a is equal to 2, from which a is equal to minus 2/5. And then in terms of eliminating a in order to solve for b, we have, upon setting s to 5, we have that 2 is equal to 5b, from which b is equal to positive 2/5. So filling in negative 2/5 for a and 2/5 for b, I have the partial fraction decomposition to be negative 2/5 of 1 over s plus 2/5 of the reciprocal of s minus 5. So we have from this partial fraction decomposition, I have upon rewriting this integration statement, so I'm going to have as tau goes from 0 to t, and I have of the quantity of negative 2/5 of the inverse Laplace transform of the reciprocal of s plus 2/5 of the inverse Laplace transform of the reciprocal of s minus 5. And again, the inverse Laplace transform 1 over s is 1. That of the reciprocal of s minus 5 is going to be e to the 5t, or in this case, e to the 5 tau. And taking the antiderivatives and integrating over tau, so we have negative 2/5 of tau. And for what I have next, okay, I have 1/5 of 2/5, which would be 2/25, and this will be of e to the 5 tau. And as tau goes from 0 to t, and we have negative 2/5 of t plus 2/25 of e to the 5t, and with the lower limit at 0, okay, now we have the variable term, and tau goes out, and then we'll have minus 2/25 of e to the 0, which in this case would be minus 2/25. So in the solution, okay, we have negative 2/5 of t plus 2/25 of e to the 5t minus 2/25. Okay, for what we have in the case of number 7, we're looking at determining inverse Laplace transforms, okay, by integrating. For what we have in 7, okay, so we had the Laplace transform set equal to 2 over s squared times the quantity of s minus 5. And for the inverse Laplace transform, now f of t, you had the inverse Laplace transform of 2 over s squared times the quantity of s minus 5. And since we have a factor in the variable s to a degree, if I rewrite this in terms of an integrating setup, okay, so I'm going to multiply this ratio by s to get the monomial that I have at the bottom down by 1 degree, so going from s squared to s. I'm going to have the inverse Laplace transform of 2 over s times the quantity of s minus 5. And I'm going to take the inverse Laplace transform, integrate with respect to the variable tau, as tau goes from 0 to t. And taking 2 over s times the quantity of s minus 5. If I put this in the context of partial fraction decomposition, again, we have two linear factors where we have 2 over s times the quantity of s minus 5 is equal to a over s plus b over s minus 5. And clearing out the fractions, I have 2 is equal to a times the quantity of s minus 5 plus b times s. We have two unknowns, but we have as many zeros that we can apply. So if I solve for A, I can set S to 0 and negate B. And in the process, A will come out to be such that negative 5A is equal to 2. Thus, we have A is equal to negative 2/5. And if I eliminate A and solve for B, I can do this by setting S to 5. So the equation becomes 2 is equal to 5B, and B comes out to positive 2/5. So for the partial fraction decomposition, okay, so we have for A over S, this would be, again, since A is negative 2/5, I have negative 2/5 of the reciprocal of S. And since B is equal to 2/5, we have plus 2/5 of the reciprocal of S minus 5. And putting back into the integral, okay, so we have rewriting 2 over S times the quantity of S minus 5 in terms of the partial fraction decomposition equivalent. So I'm going to be looking at integrating over this sum, and in this case we have negative 2/5 of the inverse Laplace transform of 1 over S plus 2/5 of the inverse Laplace transform of the reciprocal of S minus 5, integrating over dt. Okay, and so again, the inverse Laplace transform of 1 over S is 1, and that of the reciprocal of S minus 5, this would be e to the 5t. Okay, and I have not integrated yet. And if I integrate with respect to the variable tau, then we have negative 2/5 of tau. And then we have the antiderivative of e to the 5t would be 1/5 of e to the 5t. And 1/5 of 2/5 becomes 2/25. And so we have negative 2/5 of tau plus 2/25 of e to the 5 tau. And as tau goes from 0 to t, so we have with our terms from the upper limit, I have negative 2/5 of t plus 2/25 of e to the 5t. And from the lower limit, okay, now I'm going to have plus 2/5 of 0. That will go out. And I'm going to have the subtraction of 2/25 of e to the 0. And that's going to be negative 2/25. All right. Now for number 8, I have f of s is equal to 3 over s times the quantity of s minus 6. So we do have a single variable s factor, and you can use the partial fraction decomposition right away, or it could use integration. And I'll show you both ways. Now with the partial fraction decomposition of this ratio, I have the linear factors s and s minus 6 with the denominators laid out and clearing out, multiplying by both s and s minus 6. I have 3 is equal to a times the quantity of s minus 6 plus b times s. And we have two unknowns, but we have zeros that we can apply with 0 and 6. If I apply a 0, b goes out, and I had 3 is equal to negative 6a, from which we're going to have a equal to negative 1/2. And if I set it s to 6, okay, now a goes out, and we're going to have the equation to be transformed to 3 is equal to 6b, for which b is equal to 1/2. And so for the partial fraction decomposition, with values of a at negative 1/2 and b at positive 1/2, I have this ratio to be negative 1/2 of the reciprocal of s plus 1/2 of the reciprocal of s minus 6. And so just going back, so we have with f of t, we had the inverse Laplace transform of 3 over s times the quantity of s minus 6. And then taking with negative 1/2 and 1/2 as multiples, we take the respective inverse Laplace transforms of 1 over s, which will be 1, and that of 1 over s minus 6, which will be e to the 6t. And we have in the follow-through, we have for the final solution, we have f of t is equal to negative 1/2 plus 1/2 of e to the 6t. Now, if you were to choose integration, we have in this case, all right, so we can clear out the s at the bottom. So if I were to set up in terms of integrating, I'm looking at integrating over the variable tau, as tau goes from 0 to t. And we have the inverse Laplace transform of 3 over s minus 6. Not 3 over s times s minus 6, but 3 over s minus 6. And the inverse Laplace transform of this ratio will be 3 times e to the 6 tau. And we have integrating over tau, We have the antiderivative of e to the 6t will be 1/6 of e to the 6t, and multiplied by 3. 3/6 will become 1/2. So the antiderivative is going to be 1/2 of e to the 6 tau, as tau goes from 0 to t. And working with the limits, we come out to 1/2 of e to the 6t minus 1/2. And notice we have in reverse order relative to just the partial fraction decomposition, but we still come out to the exact same terms. For number 9, okay, we have f of s is equal to 3 over s squared times the quantity of s minus 6 is equal to as plus b over s squared plus c over s minus 6 if I were to opt for s squared being a quadratic factor. But if I were to treat s squared as a repeating linear factor, the setup would be a over s plus b over s squared, and then we have plus c over s minus 6. And it doesn't matter which approach you take because you're going to end up with the exact same coefficients and ratios. And upon clearing out the fractions, and we have 3 is equal to a times s minus 6 plus b times the quantity of s minus 6 plus c times s squared. Okay. And we have, in this case, we have 3 unknowns, so we'll be looking at setting up 3 equations, and we're going to have 3 values to plug in for s. Now, there are only 2 real zeros that we can apply, those being at 0 from s and 6 from the s minus 6 factor. And setting up, so I have s equal to 0, and plugging in s equal to 0 for s in this equation, we have left standing that 3 is equal to negative 6b, from which b is equal to negative 1/2. And if I set s equal to 6, positive 6, okay, now a goes out, b goes out, and we have c times 36. And with 36c set equal to 3, c comes out to 1/12. And just in terms of filling in, there are no more zeros to use, and I chose arbitrarily the value of 7 to plug in for s. And so I would have 3 is equal to 7a plus b plus 49c. And with the values b and c already known, it's going to turn out that once I isolate the 7a, I'm going to have that equal to negative 7/12, from which a is equal to minus 1/12. And with the determination of the coefficients a, b, and c, it's going to follow that for what we have here. Okay, you have the ratio is going to translate to negative 1/12 of the reciprocal of s. And when we be at negative 1/2, we'll have negative 1/2 of the reciprocal of s squared. And we have with c at 1/12. Okay, and that's going to be 1/12 of the reciprocal of s minus 6. And applying the inverse Laplace transforms of these s term factors. So we have with 1 over s, inverse Laplace transform is going to be 1. And we have with 1 over s squared, okay, that is going to be at t. And for 1 over s minus 6, that is going to be e to the 6t. So just filling in. And it's going to result that for f of t, we're going to have negative 1/12 minus 1/2 of t plus 1/12 of e raised to the 6t degree.